So now that we've discussed the Java Predicate functional interface, let's walk through the implementation of case study ex8. This case study shows how the Java Predicate functional interface can be used in conjunction with the Java HashMap class, and in particular, its removeIf method. And we'll show how predicates can be used both as a single lambda expression as well as part of a composite expression. As usual, you can find the source code for this example at GitHub, in the ex8 project, in the FP folder, in my modern Java GitHub repository. So we're now in the IntelliJ ex8 project, and let's go ahead and take a look at the ex8 file, which shows the use of predicate lambda expressions in the context of the Java HashMap class and its removeIf method. The first thing we do is we create a factor method called makeMap. And as you can see, this factor method creates a new hash map, and it initializes the keys to be the names of the three stooges, Larry, Curly, and Moe, which are strings, and it also associates the values, which are their, quote, IQs, 100, 90, and 110. And of course, this is all meant in jest and fun. The stooges were actually quite a bit smarter than those IQs because they made a lot of money pretending to be idiots. So this returns a map. Let's go see how the map's used. So the first thing we do in the main entry point into this test program is we create a local variable called stooges, which receives the map. As you can see, we treat it as a map of string to integer associations. We then print out the original map so we can see what its values are before we start doing operations to modify and mutate it. The first mutating operation we do is to convert the map into a set and then call the removeIf method on that set. And what that removeIf method does is it takes this lambda expression, entry.getValue less than or equal to 100, and it removes all the entries in the map whose value or whose IQ is less than or equal to 100, which includes Larry and Curly, just leaving Moe, who was always the smartest of the stooges. We then go ahead and print that updated map to see what changes were made to it. Next, we call the makeMap factor method a second time to create another map that once again associates the stooges with their IQs. So you can see it'll create another instance with the same values. And we print out that map to make sure we've got what we expect as the initial values. Now, however, we're going to go ahead and create two predicate objects explicitly. The first one is called IQ, and it's set equal to a predicate lambda expression, which once again checks to see whether the entry is of the value of the entry is less than or equal to 100, just like we've done up here, except now we go ahead and store this in a local variable. We then create a second local variable called Curly that has a predicate lambda that checks to see whether the key of the entry equals the string Curly. So it'll succeed if it happens to be Curly that we're dealing with. We now take those two predicate objects and we combine them together using the AND composite operator. So this takes IQ and Curly makes a composite predicate, and then we call the removeIf method on the entry set from the stooge map in order to modify the map internals. And lastly, we go ahead and print out the stooges map for the fourth time. So let's go ahead and compile and run the program. As you can see here, the first time we print the map, it has Moe, Larry, and Curly with their names and IQs. Then we remove anybody whose IQ is less than or equal to 100, leaving just good old Moe. We then make the map once again. So we have Moe, Larry, and Curly initialized afresh. And then we go ahead and just remove Curly. So we end up with Moe and Larry. So hopefully this somewhat whimsical example gives you a good idea of how you can program with predicates, both individual ones like we see up here, as well as ones that we compose together and then pass to various methods that are defined in Java collection framework classes.